excess of 400,000 deaths every year.
See if I had malaria, and well, very stupidly, I read this form that they gave to me and saw the flag as normal and thought, oh, normal means it's fine. But
Who have grown up in Africa and have not been impacted by these diseases, but there exist people in very, very rural areas which are not educated about these diseases, don't have access to clinics, and they're at the highest risk from these diseases. So we're going to take a stab at trying to solve this problem using Google's models that they've trained, and we're going to be starting out by TB detection. So Google came up with this really amazing technology where you just plug in AirPods or headphones inside your phone, and that acts as a stethoscope. And in a place like Africa, in certain areas in Nigeria, Kenya, Ghana, there are places that we can classify them as villages where people don't have access to a stethoscope. They don't even have access to a doctor. Forget about a stethoscope. So, but and here using it, go ahead and record the cough recording like I did. And we also trained the model to incorporate three additional physical features: your age, your sex, and your BMI, which are translated in Setswana over here. So then we use Google's MedGemma model, which we fine-tuned specifically on Setswana to help give us a summary in both English and Setswana whether we think the cough, the audio sound, detects any TB. So we can see here normal breath sounds, confidence 82%, low TB risk. It is very important to note that because we also assume that rural areas don't have access to internet, what we did was here produces a large embedding vector. And if you're using this on a mobile phone, you might have very slow encountering, or your phone might not even work with this. So we did an evolutionary algorithm to help optimize the number of feature vectors that to help optimize the number of features we're looking at. So to reduce the size of our vector, and we ended up from a 515 vector dimensional to a 228 dimensional vector, I believe so. As we can see here, the Setswana definitely still needs to improve. We just trained it for one epoch, so we need to, due to a lack of time, we were not able to train it for more epochs, but definitely within one epoch, we were able to get a good enough start without having any repeating tokens. Malaria detection. Normal way it works is I prick a needle in my in our blood system, and we take the blood, we put it onto what is known as an RDT, rapid diagnostic test. Now, the way it works is there are a lot of places in Africa that don't have access to clinics. So you don't really have a doctor or a nurse on hand, but you have what are known as rural workers. Right? And these are people who are often overworked, going from one house to the other, having to explain stuff to people who might not be literate. So they often tend to miss out specific signs, lines that are very faint. So let's take an example over here. Let's upload an image that we found of an actual RDT test online. My system is a bit laggy, as you can see. My laptop is the one for being laggy here. Whose first language is not English. So we're going to go ahead and do a vector search. And what we're doing over here is we're not just using any basic classifier. We're allowing our system to use MedSignLeap LP, which takes an image, produces it into an embedding, and we've used that embedding to look up through our vector search database that we created all multiple different RDTs with their test cases and diagnosis. And then what it's going to tell you is it's going to show you what is its nearest TB match, as we can see over here. And we're also able to see the diagnosis that, hey, you do